Hi, today we're going to talk about running offline evaluations in LangSmith. Offline evaluations are how you test your application to ensure that each change you make to your app improves its performance. In LangSmith, offline evaluations are accomplished using datasets and experiments. Let's start by explaining datasets. A dataset is a collection of examples that you want to test your application against. For a chatbot, this might be frequently asked questions with the corresponding answers. To create a dataset, we'll navigate to the Datasets and Experiments tab here on the left, and then click New Dataset on the right. You can see that we have two options. We can either upload a CSV or JSON-L, or we can manually create an empty dataset. Let's do it manually. You can give your dataset a name, a description, as well as specify an input and output schema. This is useful because it lets you define what fields you expect in your dataset. For example, I might expect a question as our input and an answer as our output. Cool. I've already created a dataset for our demo, so let's go there and check it out. This is the Explain Like I'm 5 golden dataset. And this is a common pattern in industry, where you collect examples of perfect or golden responses you want your application to emulate. The goal is to see if, given the same inputs, your application can produce outputs as good as the examples. I've collected some examples for our Explain Like I'm 5 chatbot. Let's take a look. Each example has an input and a reference output. For our chatbot, the inputs are questions we might get, and the reference outputs are good answers to those questions. If we want to dig into an example, we can click into it for more detail. This one is a question about photosynthesis, and the output is a good answer that a kid can understand. Next, the natural next question is, how do we add examples to our dataset? There's a couple different ways we can do this. First, we can add examples by clicking this button. We're given the option to manually create an example where we can type in the inputs and reference outputs directly. This is pretty time consuming, but it helps you ensure that you only have high quality examples in your dataset. Alternatively, we can also add AI generated examples. This uses existing examples in our dataset to synthetically create new examples. You can manually sign off on the examples that you like. Finally, the last way we can add examples is using our project traces. Let's show this off by navigating to the project for our chatbot. Click into our chatbot project, and let's select an example where we feel like our chatbot did a good job. I think this is a great answer to explain our Open Agents platform. So let's add this to our dataset. We can do this by clicking this Add To button in the top right and selecting Add to Dataset. We can then choose our golden dataset. Alternatively, we can also add traces in bulk. You can select all the traces that you like, click Add to Dataset, and then select our golden dataset. In our case, let's only add this Open Agents trace. Cool. We've added this trace to our dataset as an example. Let's go to our dataset and see it. You can see that the latest example in our dataset is this one about Open Agents platform. Now that we have all of these examples, we can demonstrate how we can use these examples to measure the performance of our application. This is where experiments come in. Let's navigate to the Experiments pane. Running an experiment will run the latest version of our application over every input in our dataset, and then compare the resulting outputs with the reference outputs in our examples. In our case, it'll ask all of those questions to our chatbot, and then see if its answers match the correct answers that we've saved. Let's see how we can do that. If we click the New Experiments button, we can see that we can run the experiment in Playground or through the SDK. Let's use the SDK. We're given some code snippets to get started, so let's bring them over to our Jupyter notebook to run. Let's walk through our notebook. This section at the beginning is the same as in our previous modules. We still load in our environment variables, and we still set up our application, the Explain Like I'm 5 chatbot. The only difference in our application is that this time I'd like to see how the O3 mini model performs, so I'm using that instead of our GPT-4o. Now we can go to our experiment setup. You'll notice that most of this is what we copied over from LangSmith. The first thing we do is import the LangSmith client and set it up. And now we can define our evaluators. An evaluator is just a function that measures some kind of metric on your application's outputs. Remember that in an experiment, our application is run on every example input. Evaluators are just functions that run on the resulting outputs. The metrics that they measure can be up to you. And depending on the type of metric, there's two types of evaluators that you can use. The first is called a custom code evaluator. These are deterministic functions that are most suited to measuring close-ended metrics. For example, our chatbot is meant to explain concepts so that even a 5-year-old can understand them. In my opinion, that means our chatbot's answers should be relatively concise so that it's easier to digest. To measure that, I've created this conciseness evaluator. It takes in our application's output and checks if that output is less than or equal to 200 words long. If it is, we say that it's concise. If it's not, we say that it's not. This evaluator is deterministic, and I've defined conciseness in a way that's close-ended. It's clear-cut whether or not an answer qualifies as concise with this function. But not all metrics you're interested in will be close-ended. For open-ended metrics, there's a second type of evaluator that you can use. These evaluators use an LLM to score the output, so we call them LLM as a judge evaluators. Below, I've defined a correctness evaluator. There's a lot of different analogies you can use to simplify a complex topic, so I use an LLM to score whether or not an explanation is correct. Our correctness evaluator defines the rubric that our LLM will use while scoring, and for each example, it gives the LLM access to the input and reference output, in addition to the output of our application. For each example, this lets the LLM compare our application's response to the correct answer we've recorded as the reference output. The final step is to define a function that allows our application to run on the input format defined in our dataset. I've created a very simple function that passes the input question to our chatbot. Now we're ready to run an experiment. To do so, all we need to do is call the evaluate function, giving it the run function we defined, specifying the dataset, in this case, our golden dataset, and the evaluators we want to run. We're going to test using O3 mini, so I've created an experiment prefix that shows we're using O3 mini. Let's run this and see what happens. It'll take a couple of minutes, so I'll see you back in LangSmith when the results are finished loading. And we're back. Let's check on the results of our experiment. We'll navigate to the Datasets and Experiments tab, click on our golden dataset, and you can see a list of experiments we've run over this dataset. We can see the experiment we just ran is here, the O3 mini experiment. I've also run other experiments on this dataset previously. I've cleaned up this section to show the experiments where I tested out other models. This includes GPT-4o and GPT-4.1. For each experiment, you can also see that we have the overall scores on the metrics we've defined. This includes conciseness and correctness. Looks like O3 mini did the best here. You might also notice that we have a score for a third metric, simplicity. This is an auto-evaluator I've defined, which automatically runs in every experiment on this dataset. This feature saves you the effort of needing to redefine a particular evaluator if you know you always want to collect that metric. To create an auto-evaluator, click on the Evaluators button in the top right. You'll see that we're given the option to create our own or use some pre-built ones. Let's click into our Simplicity Evaluator. This is an LLM as a judge evaluator, and you can see that we're given the options to define a prompt and a model to use. In our prompt, we ask the LLM to judge whether the answer is understandable by children, and we use input variables to give the LLM access to the input, output, and reference output. Cool. Let's click back out and check out our experiment results. Clicking into any individual experiment will bring up a view of how your application scored on each example. You can see that O3 Mini got a perfect score. And I'll bring this into compact view so you can actually see it. Going back, you also have the option to compare results across two different experiments. We can see in our previous runs that O3 Mini got a perfect score, but GPT 3.5 did significantly worse on correctness. Let's take a closer look to see exactly where O3 Mini performed that GPT 3.5 did not. By selecting both experiments, we can then click the Compare button, and we're now brought to a comparison screen where we can see the results of both experiments and specify the metric we'd like to compare on. We're interested in the correctness metric. If you look at the red highlighted cells, you can see which specific examples 3.5 did worse on compared to O3. If we click into the full view, we can take a better look at exactly why 3.5 scored worse. Going to this example at photosynthesis, it looks like 3.5 oversimplified compared to O3. 3.5's explanation of photosynthesis doesn't mention water at all, whereas O3's does. Pretty cool. Today, we learned how to use LangSmith to run offline evaluations. Thanks for joining me, and I'll see you in the next video.